using solubility rules. When we talk about solubility, we're talking about whether a certain substance like salt will dissolve in water. And there are some rules, and these are just rules that were found by, actually doing experiments as to what compounds typically dissolve and what compounds typically do not dissolve in water. These rules should be applied in order. So you'll be looking at rule number 1, then rule number 2, and so on. We want to start with things that are soluble, that will dissolve in water. And rule number 1, all acids dissolve in water. And remember that there are 2 ways to identify an acid. It either starts with hydrogen or it ends with COOH. So anytime you see a compound starting with hydrogen, ending with COOH, you will assume that it's soluble. Rule number 2 is that compounds that start with sodium, potassium, or the ammonium ion. And you'll notice how I have this written: sodium and any anion, potassium and any anion, ammonium with any anion will be soluble. Also, compounds that end with the nitrate ion or that end with the acetate ion will be soluble. And for these, all compounds. So basically, if you see sodium, potassium, ammonium, nitrate, or acetate in a compound, you should assume that that compound will dissolve in water. In fact, a lot of times you will see drugs that will start with sodium such and such because that particular drug is the anion, and that's a way to get it into solution, to get it to dissolve. The rest of the solubility rules are most rules. And most rules means that we've got some exceptions. So most compounds that end with chloride, that end with iodine, or that end with bromine, chlorides, iodides, or bromides, are water soluble. Things like sodium chloride, for example. But some exceptions to this are if compounds start with silver, mercury, or lead. These are exceptions. So, for example, silver chloride is not soluble, whereas most other chlorides are. And the fourth rule here is that most sulfate compounds are soluble. And there are some notable exceptions here. Probably the most important one is barium. Barium sulfate is not soluble. This is what they use for GI x-rays, and they want the barium there because barium is will pick up the x-rays, will absorb those x-rays and show you areas in the GI tract. But when you put it in as barium sulfate, it's not soluble, so you drink chalk water and then you can expel chalk water. Okay, those are the soluble. And the group of things that are insoluble are, and we're going to have this as rule number 5, most carbonates, most phosphates, and most hydroxides are not water soluble. Now, the exceptions to this are primarily the exceptions that you would have already come across. For example, if it's sodium carbonate, rule number 2 tells you it's soluble. So when you get past the soluble rules and get to this, if you see a carbonate, it means it's not soluble. A couple of exceptions are calcium hydroxide and barium hydroxide, which are soluble. And these are exceptions. And then rule number 6 is that elemental gases are slightly soluble. And this means things like oxygen, helium, nitrogen, things like that. And this also includes hydrogen sulfide and hydrocyanic acid, HCN, which are gases. They're not elemental gases, but I'll just sort of note them. So, a couple of examples for you to think about are, I'm going to write a couple of compounds here, and as I write them, take a look at how you think they would fit, whether they would be soluble or not soluble. And when I'm finished writing them, I will go over some explanations about them. Okay, if we look at the first one, which is calcium nitrate, what you should key on is the nitrate, because you will see that in Rule 2, and most or all compounds with nitrate in them are soluble, so we would expect this compound to be soluble. It would dissolve in water. The next one is silver chloride. You see the chloride. It says that most chlorides are soluble, so I need to look at what it's attached to. And since it's attached to silver, silver happens to be an exception. So silver chloride is insoluble. It will not dissolve in water, and if it's actually produced in a reaction, you'll see a precipitate. The next one is sodium phosphate, and we know that the first thing we see is the sodium. And notice that you see sodium in Rule 2, and all sodium compounds are soluble. So we stop here. This compound is soluble. The next one is magnesium sulfate. We don't see magnesium in the list, but we do see sulfate. It says most sulfates are soluble. Magnesium is not an exception. This compound is soluble. And the last one is magnesium hydroxide. Again, we don't see magnesium in the list, but we do see hydroxides. And hydroxides are insoluble. This is not an exception, and it's not in the previous rule. So this compound is insoluble. So that's an example of using the solubility rules. These will be used in exchange reactions where we can predict if we have a precipitate. That's a lot to spell, which means an insoluble product.